Okay, so Physics 11, in this little video, all we're going to do is go over 7 different problems involving common forces before you do your assignment. So if you were looking for just a few more sample problems and examples on how we were doing these types of problems involving Newton's second law and with friction and forces in free body diagrams, we'll just kind of go over those kind of all together, grouping the last few things together, and then what we'll do is I'll post the assignment for you to work on, and the assignment questions will be very similar to the types of questions that you'll see in this video. Okay, so it can often be a good source of help. Okay, so we'll just get into some problems. Okay, so there's no definitions or anything in this one, it's just looking at some problems. Okay, so in this first one, problem number 1, a 0.162 kilogram puck accelerates negatively from 10.5 meters per second to 8.80 meters per second in 14.0 seconds. Find the coefficient of friction between the puck and the ice. All right, so in this one, you might start by saying, okay, well, the thing that I'm trying to find is the coefficient of friction, right? So this is my unknown. That's what I want. And our coefficient of friction only came into play, right, in our equation where force of friction was equal to the coefficient of friction multiplied by the normal force, right? Now let's, consider the situation that we have. Well, we have a puck, right, that has a mass of 0.162 kilograms, okay, and the force of friction is essentially just pulling it back, right, because it's slowing down, right? So the force of friction is acting negatively on that particular puck. Okay. Now remember, the normal force is the force perpendicular to the surface at which the object is resting. So obviously this is resting on a flat surface, so you'd actually have force of gravity pulling here, and your normal force would be here. All right. And again, you'll notice this is an unbalanced diagram. Right, these ones are balanced, so our puck's not moving up or down, but because we don't have an applied force anymore here, right, our force of friction is what's slowing it down. Okay, so this is where we're at. We're trying to find this, which means we need the force of friction. We also need our normal force in order to be able to find mu. So we kind of just keep rolling with this and go, okay, well, what else can I find? Right, well, I can get my normal force because I can find my force of gravity, right? Fg will equal the mass times gravity, so that will be 0.162 kilograms multiplied by my 9.81 meters per second squared. Okay, and just need, there we go, wrote that down somewhere. So that ends up giving me this value of 1.589 newtons pulling down, which means that's also going to be my normal force, right? Because you can think about this acting in a negative direction, which means my normal force is the same value, equal but opposite, acting in the positive direction. Okay, so at least I now have a value here for my normal force. So again, we've got force of friction now is equal to the coefficient multiplied by 1.589 newtons. Okay. So our next thing is to figure out, well, we need force of friction, right? And yes, this is how one way you can calculate force of friction, but you also remember when we talked about force, or the net force acting on an object is equal to mass times the acceleration of the object, okay? Well, the net force of this particular diagram is just the force of friction, right? Because these guys cancel themselves out. So overall, the only real force acting, that doesn't cancel itself out on this object, right, is the force of friction, right? Or you could even write it like this. We're saying, okay, well, this is the sum of all the forces. So you got your force of friction plus your force of gravity plus your normal force equaling your mass is equal to the mass of the object multiplied by the acceleration of the object. Well, your force of gravity and your normal force canceled each other out. So really all you have is force of friction is equal to mass times acceleration. And we can solve for that because we have the mass, right? We have the mass of the object. I'm just going to actually do it over here, more space. Right? We've got the mass of the object, it's 0.162 kilograms, and we can find the acceleration of the object. Because remember, acceleration is equal to the change in velocity, Vf minus Vi, over the change in time. All values we were given, because it says in the question that we go from 10 10.5 meters per second to 8.8 meters per second. So my VF is 8.80 meters per second. My VI is my 10.5 meters per second. And it takes 14 seconds to do that. Right? So I can calculate my acceleration by doing this. 8.8 minus 10.5 divided by 14. We get a negative value there, which again makes sense because we're decelerating. Right? We're slowing down. So that's negative 0.121 meters per second squared. Okay? So now that value, the acceleration of the object, can be used with the mass of the object and the overall net force equation. Right? So my force of friction will equal my mass of my 0.162 kilograms multiplied by my acceleration of negative 0.121 meters per second squared. Okay? So when I multiply that, I get a value for my force of friction as negative 0.0197 newtons. Right? So then I can go back to this original equation that I started off setting out with, saying, okay, this is the equation that involves that coefficient, that mu value, and now I can plug that in for that coefficient, right? The force, negative 0.0197 newtons, is now equal to coefficient times 1.589 newtons, and now I just divide both sides by the 1.589. Okay, now your coefficients of frictions, they always end up just being a positive value. I mean, they obviously act in a negative direction, but we'll just kind of, think about like the absolute value of it, saying, okay, well, yes, that's the force of friction. We'll just consider it as the absolute value of it right now, so that way this becomes a positive value, right? Because it's just a constant. Okay, so we're going to take the 0.0197 newtons, divide it by the 1.589 newtons. I'll just show that. And when we do that, we get a value of 0.0124 as my coefficient of friction. Okay, and again, that's fine for sig figs because this 0 wouldn't count, so it's 1, 2, 3 sig figs, which is what we had throughout the question, right? With the mass at 3, even our velocities were all in 3 sig figs. Okay, so again, you notice in this type of question, we're still using our stuff that we had done with kinematics about acceleration, along with our Newton's laws about, our second law, the net force equaling mass times acceleration, as well as our force of friction equaling the coefficient multiplied by your normal force, right? So we're using all of that. Okay, let's look at our next question. So problem number 2, after climbing Mount Everest, Avery decides to enjoy an orange. If the orange has a weight of 3.71 newtons, determine its mass. Okay. Now, recall our lesson on mass versus weight in the fact that at different points on Earth, the force of gravity is slightly different. Okay. So I've just included it here again to take a look at. Right. So in this particular problem, Avery is on Mount Everest. Okay, so we would have to use anything that's using force of gravity, we'll have to use 9.7647, not our classic 9.81. Okay, so again, we're trying to determine its mass, so away we go. Okay, so information we have is that we know that the weight, which is the same as Fg, is equal to 3.71 newtons. Okay. When we looked up at that table, the force of gravity at Mount Everest was a value of 9.7647 meters per second squared, and we're being asked for the mass of the orange. Okay. Now this is a fairly straightforward equation here. It's just weight is equal to mass times the force of gravity. We have the weight, we know the force of gravity, we just need to divide and get the mass, right? So it would just be Fg divided by G is equal to M. Now you can interpret them as both as being positive, right? And then just get a value of M that's positive, or you can interpret them both as being negative because the force of gravity is pulling it down and gravity is a negative acceleration. Either way, you get the same value because two negatives divided by each other would also equal a positive. So ultimately what you have here is you're going to take 3.71 newtons and you're going to divide it by the 9.7647 meters per second squared, to give you the mass of the orange, and what you get is 0.380 kilograms. Okay, and again, it was 3 sig figs that we're using, so we'll include that 0 for our 3 sig figs there. All right, so there's number 2. Okay, let's take a look at number 3. So there's the table. So sample problem number 3. So here we have a question about the Top Thrill Dragster Strata Coaster at Cedar Point Amusement Park in Ohio. It uses a hydraulic launching system to accelerate, accelerate, not acceleration, to accelerate riders from 0 to 194 kilometers per hour in 3.8 seconds before climbing a completely vertical 420-foot hill. Okay, determine the net force required to accelerate an 86-kilogram man. Okay, so yeah, this roller coaster is insane. I've been to this amusement park, didn't get on this ride, not gonna lie. It looked nuts. You're just sitting there, you're sitting there on like a flat track, it just shoots you straight, and then all of a sudden you're going up. So it's crazy. But ultimately, how we do this physics-wise, right, solving this problem, we need to look at a few things, of course. Okay, so information again that we have in the problem is that our initial velocity of this 86 kilogram man starts out at 0 meters per second. It accelerates it to a velocity of 194.4 kilometers per hour. Now, in order to be able to do this correctly, we're going to have to put this into the standard units for velocity of meters per second. So remember, to do that, going from kilometers per hour to meters per second, we just divide by 3.6. And then that will give us a value of exactly 54 meters per second. Okay. It says that it does this over a period of time of 3.8 seconds. Okay. And we also have that the mass of this particular man is 68 kilograms, right? So again, if we're thinking about what's happening in this situation, it's just you have this mass that's being very, very quickly accelerated, right, with a large amount of force in this direction, okay?
Mommy.
Yes, Jersey?
Can you pause this while I go and pee?
Okay. All right. You're welcome, buddy. So once again, what you've got happening is you've got this particular mass here, and there's a huge force being applied, right? Accelerating the mass in a very quick way, right? So again, we're thinking about that. Okay, well, what are the forces acting on this? In this particular section, before we start climbing or anything like that, in just this flat section, right? The only force that's really happening is this applied force, right? If it's hydraulics, it's very minimal friction, right? It's just massive applied force is happening overall to get this, right? So what we end up saying is that, well, we use that equation where our force is equal to mass times acceleration. We're asked about what is the force, right, that gets this 68 kilogram man on this roller coaster, right? So our mass is 68 kilograms. And our acceleration, again, is going to be found using that same method, right? So VF minus VI. So 54 meters per second minus 0 meters per second over the change in time, so divided by 3.6, or 3.8, sorry, seconds. Right, so what you end up getting there is 86 kilograms. Oh, I've written this wrong. It should be 86 kilogram, man, not 68. I gotta double check my numbers here now. Yeah, 86, sorry. Okay, so when we actually do that, we see that the acceleration ends up being 14.2106 meters per second squared. So the force required to achieve this acceleration, when you do this math, you get 1,222.105 newtons, but we only actually get 2 sig figs for this question, right? Because our time here was at 2 sig figs and our mass was at 2 sig figs. So we would rewrite this using scientific notation and just call it 1.2 times 10 to the power of 123 newtons, right? Or, I mean, if you wanted to, you could call it 1200 newtons, and that still has the 2 sig figs there, okay? So that works as well, right? So that's the force required to get that acceleration, to achieve that acceleration, okay? All right, let's look at number 4. So in this one, in number 4, an 8.5 kilogram crate is pulled across the floor with a force of 75 newtons. The crate will experience a force of friction of 34 newtons in the negative direction. For the first thing, we want to draw a diagram that shows all the forces acting on the crate, okay? And we're going to determine the coefficient of friction once we have that. All right. So for this one, right, again, it's that idea of a free body diagram. So here's our mass, right? Here's our crate. I'm just going to use it as a point mass there, where the mass of this particular crate is 8.5 kilograms. Okay. So there's a few things happening. We know that's being pushed across the floor with an applied force of 75 newtons. So it's being pushed this way. All right. There's my force applied. We know that it's experiencing a force of friction of 34 newtons. So I'm going to draw an arrow backwards. We're going to draw it slightly smaller, right? Because we know that obviously 75 is a lot larger than 34. So I'm going to indicate that this arrow is larger because it has a larger force, right, versus this one, right? But this is our force of friction acting here. And then again, because we're just on a horizontal surface, we do have the force of gravity, but we also have the normal force. And again, notice how I've kind of drawn those arrows in the same, as approximately the same size. Again, because our box is not moving up or down. There's no unbalance of forces here, right? It's going to cancel each other out, so we're not going to get any overall motion or movement in that vertical plane, right? It's just going to be happening in the horizontal because we have an unbalance of forces here, right? Ultimately, this is bigger than this, so we end up getting a motion in this direction, okay? So that would be our answer for A, right? This is all of the forces acting on this particular crate, right? For B, it's asking us to find the force of friction, right? So once again, if you start thinking about, okay, I know how to do force of friction, it's the coefficient of friction times the normal force, right? Okay, well, that's all well and good. So we would need to figure out, so we were asked for coefficient of friction, so we would need, well, what is the force of friction and what is the normal force, right? Well, force of friction was given to us actually in the problem, right? So our force of friction was that negative 34 newtons, and our normal force can be calculated using the equal but opposite force of gravity, right? So our force of gravity would be done by taking our mass multiplied by acceleration due to gravity. So that's our 8.5 kilograms multiplied by our negative 9.81 meters per second squared. Okay, so our force of gravity here ends up being a value of negative 83.4 newtons. Okay, so that means our normal force is the same, right? So to find the coefficient of friction, we would just take our force of friction, divide it by our normal force, right? Again, it's just going to be a positive value here. So what you end up taking is 34 newtons and dividing it by 83.4 newtons. And what you get there is a value of 0.408. Okay. And I think this is the one that said use 3 sig figs in your answer. Nope. Okay, so I'm not actually sure why we're using 3. We should actually only be using 2, so that should actually be 0.41. Okay, so we'll edit that. And it should really just be 0.41 because we should only have 2 sig figs in that particular question. All right, moving on, we'll take a look at number 5. Okay, so at a junkyard in Brazil, specifically being told that that's at the equator, a device is used to help break down metal. The machine has a 325 kilogram metal block on its end, which is suspended from a cable. If the tension on the cable pulls the metal block upwards with a force of 3.41 times 10 cubed newtons, determine the acceleration of the metal block. Okay, so here we go with this one. So again, even though we're not really being asked for that diagram, we should still draw it anyway. So you've got this mass of a metal block, which has a value of 325 kilograms. Okay, it's being suspended, so it's just hanging in air, which means you've got a large force of gravity pulling on it, but it's also telling you it's attached to a cable, and we're being given the force of tension in the cable, right? So you've got this cable where there's tension acting on it in this direction. We've been given no information about its motion, right? So all we know is just kind of like suspended and it's hanging. So these are our forces acting on our metal block right now, okay? The question has asked us ultimately, what is the acceleration, right? So if the force of tension given to us, which was 3.41 times 10 cubed newtons, we're basically trying to figure out, well, one, is that force of tension enough that it's overcoming the force of gravity and the mass of the block is actually being pulled up, right? Or is the force of gravity larger than that force of tension and our block is actually falling down? Or are they equal and its acceleration is nothing, right? That's what we're trying to figure out. So remember, again, what we have is that where our net forces is equal to mass times acceleration, right? Well, the two forces acting on this particular mass are the force of tension and the force of gravity. Okay, now we have been given the force of tension in the question. We can find the force of gravity here, right? Fg is going to equal our mass times gravity, but remember that this equation specifically said, or this question specifically said, that we were at the equator. So we would have to go back to that table, do that real quick, and say, all right, at the equator, we're going to use a value of g of 9.7805. Okay, so when we go to figure out what our force of gravity is, it's our mass of 325 kilograms multiplied by a gravity of 9.7805 meters per second squared. Okay, so that would mean that our force of gravity for this particular block and situation is negative 3,178.66 newtons, right? So then I can use this and use this, right, force of tension, force of gravity, in my net force equation to find the acceleration, okay? So I got my force of tension here as 3.41 times 10 cubed newtons, and then I'm adding this, so it's like adding a negative, so it's subtracting 3,178.66 newtons is equal to the mass of 325 kilograms multiplied by the acceleration. Okay, so to find the acceleration, I'll first need to combine these two values, right? So subtract them. That gives me a value of 231.34 newtons, which is equal to 325 kilograms multiplied by the acceleration. And then it's just dividing both sides by 325. Okay, so 231.34 newtons divided by 325, and we get a value of 0.712 meters per second squared is equal to our acceleration. Okay, so there's our acceleration of the block. And it's positive and it's moving up. And again, that makes sense because if we looked closely at our forces here, right, force of tension, right, was like 3,410, whereas force of gravity was 3,178, right? So this was larger, so overall this would have been the winning force, essentially, and pulling in that direction, okay? All right, question 6. All right, there's just two more. We're going to take a look at 6 and 7. So in this one, if you apply a horizontal force of 30 newtons to a slide, in order to slide, 30 newtons to slide a 12 kilogram wooden crate across a floor at a constant velocity, what is the coefficient of friction between the crate and the floor, right? And that's kind of assumed as being the not static friction, but kinetic coefficient of friction, because it's already moving, right? It's not getting it started. Okay, so again, let's look at what we've got going on. So kind of free body diagram again, where we've got this mass, right? This is our mass, which is a 12 kilogram crate. Okay, it's being pushed across the floor So we're applying a force, and it's told us that that force applied is 30 newtons, okay? And it's being pushed across the floor at a constant acceleration, okay, or constant velocity, right? So if we're going to say, well, it's constant velocity, that means there is no acceleration, right? Which means, like, our F is equal to ma, right? The a is 0, and that kind of falls apart, right? So the overall, for the net force then, right, so let me just kind of show you what I mean here, is that if F net is equal to mass times acceleration, right, and our acceleration is 0, right, F net would be mass times 0, well, this whole term turns into 0, which means the sum of the forces has to be 0, right? And what you've got is a force applied, there's a force of friction here, of course you've got your force of gravity and your normal force. We're sliding a crate, these are going to have to cancel each other out anyway because they're not moving, we're not pulling it up or down, and because the acceleration is 0 and this F net of force of friction plus the force applied is going to end up equaling 0, well, and that means that the force of friction would be 30 newtons but in the negative direction. All right, so what we have already is, okay, well, that means our force of friction is going to be also 30 newtons, right, but just acting in the negative direction. Okay. All right, and ultimately what we were trying to find was what is the coefficient of friction, right? So again, that brings us to this equation of, well, the only equation that involves coefficient of friction is force of friction is equal to mu times the normal force. And our normal force is going to be equal but opposite to our force of gravity, which we can find by taking the mass and multiplying it by 9.81 meters per second squared. Right, so it'll be force of friction is equal to the coefficient of friction multiplied by, like I said, that's just going to be your mass of 12.0 kilograms, and it'll be the positive value, so 9.81 meters per second squared. Okay, and we have the force of friction being 30. Okay, so 30 newtons is equal to mu, and then when we do 12 times 9.81, we get a value of 117.72. Okay, and then so to find mu, we're just going to divide both sides by the 117.72. All right, so 30 newtons divided by 117.72. And when we do that, we get a value of 0.255. Okay, so there's our coefficient of friction that shows up. All right, so again, it's just kind of piecing a lot of little things together, right? Oh, I don't have this piece of information. Okay, well, what else do I know that I can find that and then use it somewhere else, right? It's not always just straightforward, just one equation. It's, okay, well, I've got, this is what I'm trying to find. Okay, well, this equation requires this variable. Well, I got to use a different equation to get that variable, and then you kind of keep going, right? So just kind of keep in mind everything that we've been doing. Okay, last question we'll take a look at. So here, a 411.2 kilogram elevator accelerates at a rate of 0.3421 meters per second squared upwards. Determine the tension in the cable that is supporting the elevator. Okay, so let's take a look at that one. So once again, free body diagram to start, get an idea of what's happening in this question. So you have an elevator. So that's our mass of our elevator, and the mass of the elevator was given to us as 411.2 kilograms. Okay, now an elevator is suspended, right? So you've got a force of gravity acting on the elevator, and you also have the force of tension in the cable, right? Keeping the elevator up. Okay. It's asking what is this force of tension given that the acceleration is 0.3421 meters per second squared. So if we're accelerating in the upwards direction, that means the force of tension is going to be larger than the force of gravity. So I can kind of show that with my arrows here, that the force of gravity is slightly less. Okay. So again, I can figure out force of gravity. That's not a problem. Right? It's just going to be the mass of 411.2 kilograms multiplied by just gravity of negative 9.81 meters per second squared. Okay, so my force of gravity here ends up being negative 4,033.9 newtons, right? Again, we were told the acceleration in this question was 0.3421 meters per second squared. Okay, so acceleration, how is acceleration tied in with questions about force? Well, it's using that same F net is equal to mass times acceleration, right? So we've got this, okay, the net forces on an object is equal to the object's mass multiplied by its acceleration. Overall, the net force, right, is the sum of the forces. You've got two forces acting here, force of gravity and force of tension. And you know both the mass and the acceleration here. It's 411.2 kilograms multiplied by the 0.3421 meters per second squared. And you know that the force of gravity here is the negative 4,033.9 newtons, right? So it's like force of tension minus 4,033.9 newtons is equal to, and we can multiply these two things together and get a value of 140.67 newtons. And then just to solve for force of tension, we just need to add the 4,033.9 newtons to both sides. Right, so my force of tension will just be the 140.67 newtons plus 4,033.9 newtons. We get a value of 4,174.6 newtons, but we get 4 sig figs, so this will just round to 4,175. Okay, and that's our force of tension in the cable, providing that we're moving at that particular acceleration. All right, so that was all just kind of the sample problems. Your assignment that's coming out now after this video as well is going to be problems similar to this, right? So if you're kind of getting stuck on one of the problems, take a look at the video, see if there was something similar that you can use to try and help you solve it. Assignment's not due until May the 12th, so you can kind of have Monday and Tuesday to, you know, work through this video, work through these problems yourself even, again, and then work through the assignment before you submit it, okay?